probably more smaller. We talked about that. They're just going to be small towns with well systems. There's those big cities, big treatment plants. So there's probably more small public water systems, PSWs, are well systems, but there's more of them. Trailer courts, churches, any place that feeds more than 15 people is called a public water system. Cincinnati, Toledo. You go to smaller towns, Stryker, Fayette, they all have their own water system, public water systems, PWSs. But a lot of them are wells. They have big wells in their town that just pump the water up. They might put a little chlorine in it and then pump it out. We're actually treating the water here. Right now, the biggest micropollutant we're dealing with now is microcystine. It's an organic. It's from the algae. I don't know if you guys remember Lake Erie turned green and they had a big uproar about it. But that's the big thing right now is microcystine. I can't tell you the other names. There's other names. It's after the chlorine goes in and kills the organic, it's what's left. It does turn toxic. We need to get it out of the water. So that's our biggest concern now is we can aerate the water, which we're doing. We're pumping the air into the water, and we are going to build a GAC system, a granulated activated carbon. Like them big filters we had in the front, them 3, we're going to put 9 of them out there, but they're going to be 3 times as tall with activated carbon, and that's going to catch it. Colleges and universities have been studying this for 4 or 5 years now, and if they come up with aeration and the GAC system, I'd say yes. There's also in-field proof. Another thing I was talking about, we aerate our reservoirs. They're also putting aeration in water towers, storage tanks. You just can't keep water around forever and store it. It gets stale, it gets worse. You gotta move that water. So they're aerating it and circulating it, and that's the proven works too to help with this THM problem. The rules, well, I don't know how to
The regulations.
Regulations, EPA, I mean, we want to make clean, pure water for you. But as soon as we get one thing, okay, this is going to work, somebody finds something else in the water, so we have to change our treatment process, spend the money, do something different. That's been a hassle over the years, but it's only for the customer, the benefit of the public. THM we've been talking about, the leftover after the chlorine on the organics. It is so small, our filters don't catch it. Not just ours, everybody's. It is such a small, so we have to put in finer filters. Or we aerate it and we gas it off, is what we can turn it to a gas so small that it just disappears. Really just for the micropollutant, I'm going to say all of them. We're using lime, we've seen that in big silos, the ferric, that was the glue. We're adding carbon to absorb the taste and odor, the organic. Permanganate, oxidize it, get oxygen in the water, helps. Then the finished chemicals are chlorines, our fluorides, our phosphates. There isn't like just one chemical that's going to take out THMs. That's just not there. The micro. I mean, I'm considering all ours as micro. organics and stuff, so that's the chemicals we use. There's also soda ash, alum, different chemistries of water, different chemicals work better. There's polymers, this is what works for our water here. Organics. Farm fertilizers, cow poop. They poop on the ground and it runs off, gets in the brook, and that's your E. coli's and your ducks going out there pooping. That's all E. coli.
Remember they had something that Michael called that's on the duck's legs. What do you call that?
Duckweed. Our thing is organics right now. We can get the minerals and that comes out with the lime softening, but the organics, a little smaller, a little trickier. Over the years, the industry's just killed them. Well, that leaves the stuff behind. That's THMs I'm talking about. EPA's regulating, they want that out too. So we do clarification. We can call that sedimentation. There's different ways to do it, but we usually clarify. You're trying to settle it. We filter it. 2, 3, we finish it up with our chemicals. Chlorine or fluoride? You can answer that. How was the tour? And we stood over in here and we talked about 6 parts per million will kill you. One sniff will kill you. What was that chemical? Chlorine.
And what did he just say? He puts the other one in for his teeth.
For your teeth. Fluoride. It's in your toothpaste, your mouthwash. So the answer to that question would be yes. We do have chlorine and fluoride in our drinking water. One person can run the plant, but it takes, I think there's 9 of us work here, the whole operation. But there's 9 of us in the department to keep the whole department running. But the way the question was asked, we could run this plant with one guy. It was a lake up in Michigan, started with a D, Delphos Lake. That's where ours comes from. I had that little picture on the wall. I know it didn't make sense, but whenever it rains up there, rainwater goes in the creeks and the streams, and then it gets in a river, and then it makes its way to us. We pump it, put it in our reservoir,